Hi there. Well, welcome everybody. Thanks for joining tonight's session. Today actually is going to be all about real-time streaming in Azure. Actually, is a subject I'm looking forward myself to learn as well. Yeah, by the way, I'm Jackson Felden, one of the members here from the Cloud Lunch and Learn. Before I do a proper intro for team, just make sure you scan the code here on the screen, or you can follow the link. I will paste the link in a few seconds. And then actually from there, especially if it's your first time you are joining our community, you can get some additional material from Microsoft just to kind of go a little bit beyond what the team will show all of us today. And then for us and for Microsoft, it's always good to know how many people are connecting and enjoying this session. Okay, let's say the schedule for today is 1 hour. And Tim, do you want to do a quick intro before I, let's say, make your screen available?
Sure. I'm Tim Spann. I'm a developer advocate at Stream Native. We do Pulsar and Flink, in Kubernetes and in all the awesome clouds, especially Azure. So that's what we'll be talking about today.
Okay, great. Yeah. Okay, I think that's it for now. In a few minutes, I will paste the link for our Ideathon challenge. Today, we are still looking for people to join this, how could I say, community challenge. The challenge for this year is to put some bright minds together to try to improve the air quality in Bahrain. I will post the link in a few seconds, and then that would be great if you could join this community challenge as well. Okay, Tim, I will share your screen. Just give me 1 second.
Sure.
Okay, I believe the floor is yours. Tim, I forgot to ask, do you want to keep the questions at the end? Or when the questions are coming, should I interrupt you and just ask, let's say, on fly?
Let's interrupt on the fly so people don't, if they get disconnected or forget about it. If something comes up, let's do it then.
Yeah, okay. Okay, that's great. Yeah. Okay, Tim, I will be here on the background if you need anything. Otherwise, have a great session. And as I said, I'm looking forward to learn with you as well. Okay, the floor is yours.
Very cool. Let's get into it. Now, this is real-time streaming in Azure, but it's anywhere. And that challenge that he mentioned, I think I'm going to have to see if I can assist there, because some of the things I'm going to show you today are actually related to that. I actually have an air sensor over here. I'm ingesting some of that data and streaming that. What's nice is I'm streaming that to wherever it needs to go. And very often that's applications running in Azure. But the nice thing is, say pieces of that are local or pieces are on a device. Doesn't really matter. They all work together. If you see anything interesting, definitely contact me. But I'll make sure that the slides and any of the source code will be available. And you'll be able to go deeper if you're interested in what we're doing and go from there. I just wanted to do a quick shout out to where I'm working at Stream Native. We're a startup that is founded by the original people between Pulsar and Bookkeeper. And we do all these pretty cool cloud native event streaming on various cloud and Kubernetes platforms, really making it easier. It's pretty easy in the cloud already, but it's nice to have someone there to help you with monitoring and all those sort of fun things. But let's start off. What is Pulsar? Now, there's a lot of different open source software out there to help you with messaging. What's unique about Apache Pulsar is it's really designed to be cloud native, and it's designed to do messaging and streaming, which aren't the same thing. And that's something that we'll go into. But when you see the differences, then you'll know, oh yeah, that's why sometimes I was using one thing for messaging and something else like Kafka for streaming. And you see why doing it in one, geo-distributed platform is nice. Pulsar had a couple of things in mind when it was built by Yahoo. Some of the ideas were around making sure it supported multi-tenancy, so you could have lots of different people there. So say you just build one cluster, but that way no one's stepping on each other's data. Obviously, you need to be scalable today. People are spinning things up in whatever availability zones or locations around the world, maybe in different data centers, different clouds, different regions. You got to be able to scale out wherever that is. Obviously, if you're scaling out, but you have data in different parts of the world, you're going to need to replicate that. That's built into Pulsar. When we talk about unified messaging, there is one cluster that handles any kind of messaging you need. And very important for a lot of messaging is making sure that data is durable. And we make sure that's extremely durable, that you keep your data as long as you need to, and you decide when it expires or what do you want to do with it after it reaches a certain age. Very important there in messaging. Apache Pulsar has a rich ecosystem around it, depending on where you are in the wheel of usage. If you're doing messaging, support all the languages that you're going to want to be using. You know, things like Go and Java and C++ and .NET and Python, and, you know, lots of different ways to get to the data. You know, we also have means of doing that via WebSockets and via different protocols. What's nice with Pulsar, say you don't want to use native Pulsar protocol because you have code in place, or you're using third-party projects that use some library. There are a ton of adapters and it's very extensible. So sometimes I'll use the Kafka protocol. Sometimes I'll use MQTT. Sometimes I'll use AMQP. Lots of options there on how you communicate to the messaging brokers. What's nice too is if you don't want to write any code or write very little code, there's built-in IO modules. So once you get your data into Pulsar, could automatically stream it into, you know, maybe cloud storage, maybe into something like InfluxDB, a Postgres database, SQL Server, whatever it may be. If you're going the other way, change data capture to automatically grab from different databases, stream that into your topics, have anyone else do with what they want there. Support for all the different cloud native storages, very low latency access to that storage, ability to have functions in a stateless function mesh, execute when things happen in a topic, makes it easy to do some kind of ELT or machine learning or extra processing on that data without having to pull it out of the topic. Being able to do interactive queries on that data while it's still in the topic, and being able to do continuous SQL events as they arrive into topics with things like Spark and Flink. We talked about unified messaging. We're pretty serious about that. There are different types of messaging out there. It's generally two types. Messaging as queues, where you get data comes in and you want to pull it out. Maybe it's multiple people. The main thing to think about here is sometimes you use these as work queues. Sometimes these are used in the front end. Sometimes lots of different use cases here, lots of legacy apps here. Another thing to think of here is you don't usually care about the order. You want something comes in, process it, and have as many people potentially processing it as possible. Order is not important. In streaming, I want to deal with events as they come in. Order is important. Also, I want to do things like exactly once, or maybe at least once, or at most once. There's lots of different things related to the ordering and the timing of data. We support that as well. That's similar to Kafka and Kinesis. Do we have a question? You are muted. You are muted. Why do you still need Kafka? Well, as an Apache person, I say all of our projects in Apache are awesome. Do you need it? No. I mean, you could use Pulsar instead of Kafka, especially since it has built-in sources and sinks to grab data from Kafka for you or put it into Kafka. It also has what's called Kafka on Pulsar. This lets you use Pulsar as if it was Kafka. To any of your use the standard Kafka libraries, you don't even have to tell people you're not using Kafka anymore. But, Kafka is pretty mature. There's no reason not to have both. But yeah, if you don't want to have two messaging platforms, Pulsar can be your unified messaging platform to replace all of these products and more, and do all them at a tremendous scale. With something that's pretty cool is it separates storage from compute. As cloud people, that's a no-brainer to you, and it's something that you expect. Well, Kafka doesn't do that yet, but Pulsar does. When messages come in, they're handled by brokers. These brokers are stateless. They store all their data in Bookkeeper, so you've got that separation. So if you need to scale out how many consumers and producers or how much compute you're doing, you scale up your compute with your Pulsar brokers. If you need more storage, you could scale out your Bookkeeper, or you could start having data tiered out. Tiered storage is supported. So as data gets past a certain size, you don't have to worry about creating these massive Bookkeeper nodes. I could just, stream out that data right into native cloud storage, which is really nice and obviously cheaper than maybe a fancy node or even a fancy container you might have out there that may be using SSDs or may cost more money. Put that in the cheapest storage available. That obviously extends out to whatever size you're willing to pay for, which is very affordable. Now, there's what's interesting versus Kafka, which I came from the Kafka world, and this was interesting to me, is there's different ways for you to consume the data. This is how you decide if you're streaming or messaging. With the key shared, multiple consumers can use the same set of keys, and that way, you could get it streaming in order. You could do something where you have a primary consumer. If there's failure, it goes over to a backup. For messaging, you could have an exclusive consumer getting everything from a subscription. And, that's kind of common for some kind of some consumer systems out there. Shared, just whoever wants the message, whoever gets it first, they get it. This is really good for scaling out, say, workers. Process the data as fast as possible. I don't care about order, don't care who does it. I'll have, say, 100 non-unique consumers that are just doing whatever they need to do, and they're idempotent, they're isolated. Maybe these are containers, maybe these are pods. Whoever's doing it, I don't care. Just get that data and process it as fast as need be, and I could just keep spinning up more, and it's just shared among all of them. That's great for performance. That's something common in some of the old JMS and other messaging systems. There are definitely a lot of use cases there. So what's nice that you could pick which one makes sense for the applications, and you could even do that, on the fly. So it doesn't matter, you don't have to make these decisions early on and never change them. These aren't fixed partitions. There's not things that can't be dynamically changed. Gives you a lot of flexibility there. Pulsar, again, was designed for the cloud. Having the separation of compute and storage makes things very easy to scale. Built for Kubernetes, we've got the production-ready Helm charts and operators out there. Being able to use cloud storage, so you can make these streams as big as you want, and have Pulsar manage it. So if you want to do something like Pulsar SQL, or you want to read back to old data, you don't have to manually manage data in other data stores. So if you need to do replay when you're reading from one database and pushing it to another one, you could go back as far as you want with infinite durability if you're willing to pay for it. But obviously, cloud storage is a lot cheaper than having a whole bunch of SSDs. So what's nice is lots of different workloads, lots of different teams. All the workloads can be isolated. You don't really have to worry about, making these decisions beforehand and getting punished if you make the wrong one. A lot of flexibility here, a lot of extensibility. and running natively in whatever cloud infrastructure you need. Jack Van Lightly made this really awesome picture here describing one of the interesting differences between some other messaging and Pulsar. The scale out is when I add another broker, I don't have to go, how do I rebalance this later? Remember, the data is not in the brokers. Data's in the bookkeepers, and there's Zookeeper to assist in making sure data goes to the right place and metadata is managed. And again, those things are extensible and open if they need to be, extended or enhanced in the future. Easy to do, but easy for scaling out. Things are slowing down, throw some brokers in it. They start automatically taking on load when it comes in. No need to run special code to rebalance or try to figure out how to handle the load that's going on. Very nice feature there. As someone who might be new to Pulsar, there's a lot of people who aren't new to Pulsar, and they're pretty big, and they've been using it for a while. And the nice thing here is maybe you only have a few 100 million messages a second you're dealing with, and you're like, well, maybe I don't need the power of Pulsar yet, but maybe I like that flexibility. The nice thing is you could start small with a couple of brokers, process some data, or even start standalone. Run one Pulsar broker just to get it for some apps to test it out. You don't have to worry. You can scale up as big as possible and know that Pulsar can handle that regardless of your size, regardless of your use case. It's built into a lot of infrastructure that you may be using already. Pulsar is pretty powerful. If you look at some of these names, these are not people who take software lightly. Now, Pulsar didn't start yesterday. It's and the last couple of years, it's really accelerated and grown a lot more powerful, but it's been around for a while. Yahoo was using this because they had an issue a lot of people had with the cloud. Some things need streaming, some take messaging. You have lots of different workloads. Be nice to have one messaging system for all that. That's what we have now. Lots of new features keep coming out. Lots of partners out there in the community, lots of different contributors, work on different adapters. What's nice is being able to just add something like Kafka on Pulsar, AMQP on Pulsar, without taking away from what you have already. Very easy to add extensions for maybe other protocols you might be working with. I want to go a little deeper here, but I don't want to waste all the time going too deep. We could always go back to this, and I'll make sure you have the slides just to give you a feeling what's going on in the system. You have those different brokers. They are just for compute and dealing with cache and different things like that to make sure that's how your clients interact. They interact with the bookies, which are the bookkeeper nodes that handle the data. Zookeeper is in there to make sure everyone's exchanging metadata. That's extensible and that may be changed, but right now that's the architecture. PubSub built in. We meant that geo-replication. Don't have to add anything else there. Pulsar functions act like stateless functions, operate on things in the topics. That's for small apps. Maybe I'm dealing with one topic. Maybe it's validating data. Maybe it's adding a field, changing a timestamp, doing some math, something simple. Scale out very easily. Multi-tenancies built in. So there's tenants, there's namespaces, there's topics. Very easy to keep different users separate. So you can put your whole company on one cluster. Having that tiered storage, so you're not worried about really heavyweight nodes that are a pain to scale up. You can use lightweight nodes, a lot of compute. Store some in bookkeeper nodes, rest tier out to your storage buckets. Lots of connectors out there, so you don't have to write apps. I could just set a couple of configurations, tie it to a topic. When data comes in, automatically gets stored somewhere like a database, like a NoSQL store, like cloud storage. You know, whatever makes sense for you there. There's a ton of them there. Easy to write your own. REST API to manage everything as you expect. Same with a couple of command line interfaces. So you can do any kind of DevOps you need to do. Lots of different clients. Some that are a bunch that are supported out of the box and a ton of one that are third party. Pretty easy to write your own. We mentioned those different types of subscriptions. Let's let you decide if you're doing streaming or messaging. Support for all those different protocols plus more. I like having MQTT because I have a lot of devices. And with devices, they like to speak very often MQTT. Instead of having to rewrite them or put custom libraries on there, I could just call Pulsar as if it was an MQTT broker, but one that's geo-replicated, very extensible. It has lots of other features, but the apps that are pushing messages to it don't have to know that, which is nice. Lots out there in the ecosystem. We'll go through that. As I mentioned.
Tim,
question?
Yeah, can I ask a question myself?
Sure.
I used to support loads of Microsoft partners, and then talking specifically about Azure, of course, cost is something that's always, comes to any small or massive project. And then if you are, maybe you're talking about cost, if later on, but in general, if I'm using Azure to do all those streaming, I will pay for storage, probably traffic. Is there any other kind of important component when it comes to cost? If you have a slide to talk about later, that's fine. Just something came my mind.
Pricing. I don't have a specific pricing slide. That is something I should look up and I'll post in the post after. But the costs are, like you said, networking in and out.
Yeah.
Are you going to have firewalls, that sort of thing? What's nice is you could use that blob storage, keep it as the cheapest storage you can get from there. What's nice with Pulsar is it is pretty lean. So a couple of nodes of Pulsar, like if I have 3 Pulsar nodes, keep them pretty small. We're talking, not the biggest, tiers of VMs or Kubernetes pods.
I see. That
helps.
And
a couple of those, maybe 6 or 9 nodes will support most businesses. A lot of data. Like I'm running on a single instance and I could support hundreds of thousands of messages a second. Now,
okay.
Well, once you start spending a lot of money and you have a ton of data going on, yeah, you'll start adding more, but you can get a lot done. And those front end Pulsar nodes that are handling the compute can be really lightweight, don't need much storage. You're better off maybe using cheaper, smaller ones and just have a bunch of them. It doesn't take much.
Yeah.
And if you keep your apps running in Azure, you're not having the networking coming in and out, right?
Yeah. That's the beauty of the cloud. You could start small, and then if you need to just add more resources and
adding a broker
from there.
instantly gets
That's it,
used. So you don't have to plan beforehand and go, well, I'm fixed at 7.
Yeah.
I better build it as large as I want in the beginning so I don't have to do anything. Add, take away. If that's too many nodes, take one away.
That's it, yeah.
It'll just distribute it to the other places. And since the data's not on the brokers, you don't even have to worry about that when they take them away. The data's there. And, you could have, since the data is permanently stored in cloud storage, you could shut down the whole thing, bring it back up, and start processing again. It could be as stateless as you need to be. Designed for Kubernetes, so very easy to scale up and down. Or you could put it in a very simple VM environment. You could even, if you're doing the kind of messaging where you're like, while things are running, I need to send the messages there. But when I'm done, I don't need anything. You could run one node of Pulsar in standalone mode, have it support as much as you need, and you go, okay, I'm done with that. Shut it all down.
Oh, that's it, yeah, and keep the cost down.
What's nice is you don't have to predefine things. The first time I start pushing data to a topic, it'll build the topic for you if it's not there. So you could run with very little maintenance, especially if it's something where I just want to use this as my conduit to get data from point A to point B. Start it up, start sending data to it. It'll start, making it available to whoever's subscribed to it. And then when you're done, it goes away.
That's it. Yeah. Okay. Okay.
So
Great.
you
Yeah.
can keep
Okay.
it pretty cheap. You don't need
Mhm.
to keep things running. You don't need to run maintenance. And if you're using cloud storage for the permanent storage, when you bring it back up, there's your messages.
That's it. Yeah. Okay. Great. Yeah. Okay. Thanks for that.
Yeah. But yeah, if you want to spend more money, you certainly can. We also have at Stream Native, we have a cloud hosted solution if you don't even want to have to think about it. And then, you could pay a fixed fee or based on usage, and then you don't have to worry about, managing these systems yourself. But again, it's pretty simple, especially depending on what you need. Once you start asking about 5, 7, whatever the many nines there, then you may want a partner like Stream Native to make sure, everything is set up there and, it's as many duplicates as possible. But for a lot of use cases for messaging, I just need something there so I could start sending data. And then when I'm done, stop. It's very easy for you to consume and produce these messages. Lots of different ways to do that. The code is very straightforward and simple. If you've done JMS or any kind of cloud messaging or Kafka, it's that simple, if not simpler. And support for almost any programming language you want. If you don't want to do programming, there's things like Apache NiFi that I'll do a quick display of. I think we still have time there to show you how easy it is. If you don't want to write code, there's all these built-in connectors. So like I said, you turn it on and maybe you're like, I want to get data out of my Mongo. Maybe it's on Azure, maybe it's somewhere else. Turn it on. Pulsar will pull it out of there, put it in a topic, and you can put a sync, have it synced into blob storage. And then when you're done, or maybe you've got all the data out of that database and you're going to destroy it, you shut down Pulsar and be done. So there's ways you could do things with low or no code there. The blob store offloader is nice. Like we mentioned, it keeps storage in those little bookkeeper nodes unless you want to turn on tiered storage. And the tiered storage for Azure drops it into that block storage, and then you have it permanently in there. You could also have it act as we mentioned, these sources and sinks. So you could have data coming to and from whatever you need to do there. Pretty straightforward. One thing that's nice feature, I don't know if you've heard of Trinol, used to be called Presto SQL. This is underlying later if you want to turn this on. Again, this is something that could be turned on if you're interested. Pulsar SQL lets you read the data that's stored in these bookie nodes or from offline storage. So if you want to see what your data is, you could use Pulsar SQL underlying Trinol to write apps against your data while it's in that storage, whether that storage is for long term or while messaging is happening. This happens whatever's currently there. So this is for maybe I want to do metrics. Maybe I want to see the state of my data. Depends on what your use case is. This is the way to do that. This is not the only way, but I just wanted to show you that. It makes it nice. You don't have to create tables. You don't have to do any extra work. You put the data in the system and you have it as tables. Depends how you store it. We don't force people to store it in a certain way. It could just be bytes. It could be JSON. It could be protobuf. It could be Avro. Lots of different things can be in there. What's nice with Pulsar is we got a built-in schema registry. So if you do have a schema with it and you use the appropriate libraries, it'll have that schema loaded into the schema registry. So it'll automatically know all those fields and types when you do SQL, whether it's for Presto SQL or my friend here, Apache Flink. Flink runs on, obviously, Azure or any cloud you might have, or on your desktop or Docker if you're playing it out. What makes this a little different from that Pulsar SQL I just mentioned is when I run the SQL here, it could be continuous. So it could be deployed as an app. So what happens is I write select, some from this topic or 2 topics, run, it keeps running. It'll hit the data that's there now, but as you add events, those show up in the query. So your query just keeps running and going. What that means is I do a query, I want to get a sum. I could just have that in that local storage there, or I could push that to another topic or run any kind of Flink code, which is Java or Scala or Python, and have it do something. It could be the simplest use case I like to do is look for anomalies. Like I'm doing IoT. I want to look for data outside of a certain boundary, maybe in a certain time period. What's nice with this special case of stream processing is set a window of time, say 15 minutes. If there's, a value that's above something in these last 5 minutes, do something with it. Maybe the minimum thing is insert it into another topic. Once it's in a topic, any consumer app or sync can get it. So this might be alerts. Maybe this goes right to a dashboard. Maybe this runs some machine learning. Maybe this triggers a Slack. Once it's in its own topic, you could do whatever it needs to do. You could do ETL by combining data, running functions, whatever you need to do there. The SQL is very rich. It's by Apache Calcite, which is used in a lot of other tools. But here, streaming analytics just need to know SQL. Pretty straightforward. What's nice is when it's deployed on a Flink cluster. Flink scales out ridiculously well and works great in Azure and any other cloud. This is used in infrastructure under a lot of different large products by some very large companies out there. This is a great way to do your data. And what's nice is I could put inserts in there, insert that into different topics, do selects. And here you're writing stream processing, event processing in real time against really big, fast data. And all you had to do is write some SQL. This is a very nice way to do that. Makes it really easy to scale these things out. And it works really well with Pulsar. So it makes it nice to be able to use these 2 open source projects together, wherever your different streaming needs are. Again, to show you, there are some pretty big companies out there using it, and they're using it at pretty massive scale. Again, is another great Apache project out there.
Sorry, Tim, we got another question here.
Sure.
In regards if there is anything simple like it,
Yes.
like the Kafka Connect.
Yes. I'm trying to think if I showed that slide already, but let me quickly go back. Yes, we actually do support Kafka Connect, but our connections are, similarly called connectors. If you go to the hub there, you'll see a list of some of them. It's the same idea as Kafka Connect. Either it's a source or a sink or something in the middle does some processing. Yeah, if you want to use something like a Kafka Connect connector, that is the Pulsar connectors, Pulsar IO. It looks the same. There are ways to run Kafka Connect connectors as well, but I'd say use the native ones. Now, the closest to KSQL or KSQL DB, if you're still talking Kafka Connect, is Flink SQL. The Pulsar SQL runs at a time. KSQL like this runs continuously. The equivalent of Kafka streams is the Pulsar Functions. These things work extremely similarly, and same ideas really. Now, what's unique about, say, Flink? You're thinking Flink like Spark. Yeah, we support Spark. Spark is a little different, as Spark is batch and micro batch. They're moving to streaming, but Flink is stream first, stream only, stream ever. So if we ever do batch in Flink, it's really a stream. It's in, a special use case there. It makes it nice whether you're bounding a stream or it's an unbounded stream, different types of events. This could get pretty complex the way that Flink works. It's not a talk on Flink, but rest assured that it handles whatever you need to do with streaming. Obviously supports the SQL on Pulsar use case and a lot of other use cases. They have a lot of their own sources and sinks. So again, if you don't see a sink in Pulsar, you could use a sink or a source from Flink. You could use a source or a sink from something like NiFi will show you, or with our connector to Kafka. If you have some connectors maybe you wrote and you don't want to rewrite them yet, keep a Kafka cluster running and have Pulsar communicate to it and share those messages. Pretty straightforward. Again, straightforward as in I'm streaming among multiple clusters and possibly different parts of Azure. It's still a little complex. As you imagine with all these things, build up graphs of tasks, of distributed runtime among different containers, whether those are running in VMs or Kubernetes pods or Docker containers. It gets pretty complex. Same kind of idea that originally was there for Hadoop, was there for Spark. There's only certain ways you could do it. This just started a little later, so it's has its own little, how it's clean or it's not clean. It's, same idea. Lots of different APIs here. Now, I like the Flink SQL one. We host that in Stream Native. I just need to know SQL. I don't need to know anything else. That's kind of helpful. Democratize how you access the streaming data, and you could still write most of the apps you need. Sometimes someone's going to want to write some code, table API. So if I don't want to run SQL, there's an API to do that programmatically. I could go down a layer, get a little more complex and do streams and windows. If I need to do stateful, this is nice with Flink. I could be stateless or stateful. Sometimes you care about state. Again, this could be I'm running aggregates. I want to sum over all the data ever, those sort of things. Or I need to maintain state for other purposes. Maybe there's a company out there you might have saw on there called King. They use that for high scores. That's something you might not want to lose. So having those state out there is important. Flink is pretty cool. Like we mentioned with those SQL looks like regular SQL, same you're using in SQL Server or whatever database you may have. The difference is you take in the stream, make it seem like a table, and you're incrementally executing this query as new events come in. There's a couple of extra things added to SQL that only make sense in a streaming context. Things like tumble that say, let's look at a window or segment of data, in this one, whether it's a second, a minute, an hour, whatever it is, to say, I'm just looking at the average for this rolling window of data. As new data comes in, the time moves forward. I'm looking at that. Lots of different ways you could do these things. This is when you start looking at windows and time, things get complex, and maybe there you you take one of the multi-day courses and go, okay, I understand what's going on with windowing. Again, it really depends on your applications. Very often, select star. I just want to get the data and maybe put it into another topic with a SQL. Pretty easy. We like that one so much. We put that in our native cloud there just to make it easier. Pretty straightforward there. Let me just go through that. Okay, this is a little bit of the infrastructure to give you an idea. There's that app layer. What's nice is because of the different ways we're doing messaging, you can put this in a mobile app and a web app and a microservice as part of your data processing and dashboards and Jupyter notebooks and all those sort of things. App layer is pretty flexible because there's multiple ways to access your data, whether it's through a Pulsar client, which includes things like Node.js, or through something like WebSockets. And there's also lots of adapters out there in the open source if you want to do something like REST or something else. Compute layer, couple different ways. We mentioned the functions are like K-streams, Flinks, and Flink SQL. You do things like KSQLDB. Pulsars, doing that, the necessary computing to get those topics managed. Bookkeepers storing it. But if you need it to be tiered out, you could decide when it gets tiered out and where. best way to run this, we generally run it on Kubernetes, and that could be on top of any of the clouds or, in the old world data centers or wherever you need to run Kubernetes. Pretty straightforward and clean to do this. We make this a little easier by having it in cloud there. If you're running it on premise, make it a little easier to have some of our add-on admin features in there to make it a little easier to manage. I'll go through some of this. I don't want to spend too much time on NiFi, but I'm going to show you that in a demo real quick. NiFi is another nice piece of the open source for streaming. It lets me do a lot of simple routing data between places, do some simple processing. It's a nice way to consume data and produce data to Pulsar and do some things that I don't want to have to code. This does this in a flow style programming with very low code. This one's pretty scalable out there. One thing that's nice with NiFi is something called provenance. This gives me a data lineage of everything I touched. This is really nice to know where my data come from, where'd it go? Well, to be able to see that real time while it happens, or through command line interface, or push that to, Grafana or Prometheus or something and see all that. Nice features. Being able to dynamically change back pressure and priority of data as it's coming through the system. Cool feature. Being able to see everything with diagnostics, whether it's through command line, through REST API, however you want to see what's going on with your system. Again, you can run this in VMs, containers, or Kubernetes and have those pulled out and automatically adjust and add nodes, remove nodes as those things happen. We have data comes through the system. It's called a flow file. You could add metadata around it. I don't want to spend too much time on NiFi here. I've just put these slides in here so you'll have them when you get going. And in case I ran out of things to talk about, but I didn't. What's nice with NiFi and also with Pulsar and Flink, very easy to add your own components, even if they're deep learning. This DJL library out there is really cool. If you like Java, makes it very easy to do deep learning, whether it's PyTorch, TensorFlow, MXNet, different things, and deploy it in a JVM environment, which is a lot of different environments, whether it's in Azure and any other place. And NiFi can use these. Makes it very easy for you to add some deep learning to a flow. I have a couple different use cases I'm going to show. IoT is a nice one because it's some unique data, not the same data everyone's using. So I'll show you a little bit about that. Also show you some REST data, some stocks. This is the general idea for the demo. I'm just going to show this real quick and then jump into it. I have some sources of data. NiFi is one of the ways I'm grabbing that data, pushing it into Pulsar, then distributing it where I need to go. I'll get into the rest of the slides in a minute. If I could find my cursor, here we go. Now, I'll leave it here and then start with the demo. I am on some of my devices here. I'm going to have them start running data. What's cool with these demos is that they are running on different devices. I got one running on NVIDIA. One's running on Xavier. One's running on a Raspberry Pi. And these are grabbing sensor readings, energy readings, different types of things here, and then pushing that data to Pulsar. Some are pushing it through native Pulsar. I have a Go app doing that. Some are doing MQTT. The energy one is pushing it through WebSockets. Lots of different ways to push your data into Pulsar, which makes for a great way to distribute data. This is NiFi. I just wanted to show you how I manage that data. So here for this use case, I have some data I'm pulling in through an RSS feed. Yeah, there's still XML out there. There's still RSS. You wish there wasn't, but the local transportation authority near me to give any of that real-time transit data, they put it in an RSS file. So I process that. That's a nice thing with NiFi. No code. I'll just let NiFi convert that data from RSS to JSON, add a timestamp, add a unique ID, do some cleanup, and then I'm just going to send it to Pulsar. My system doesn't crash here. Depends where you're running it. And here, when I'm running that deep learning, I'm out of memory. I need to make some bigger sizes here. So I'm going to dynamically stop all those. So that one is grabbing the data, pushing it, cleaning it, and then sending it to Pulsar. So I could do things like route it into my cloud and have that available to distribute wherever it needs to be. What's nice when I use the Stream Native Cloud, it handles all the cluster for me, all the configuration. I just care about who are my users, what are the different tenants, what are the namespaces, what are the topics I have, what's the schema, all that sort of thing. What do I have permission to? What don't I have permission to? All those sort of things that are, could be a lot of work, but I don't really have to worry about. I don't even know which cloud this one's running in. Doesn't really matter to me. It matters to whoever's paying for it. So if today's one's cheaper than the other, I could switch or have, maybe I have one cluster on one cloud, one on another, have Pulsar replicate between them. Or, maybe I'm moving off of Amazon and moving to Azure, have Pulsar replicate that data over for you. And then when you're done with Amazon, shut it down. Those sort of things, pretty easy to do. This schema was auto-generated for me from a model I had that I was pushing data into this topic. Pretty straightforward. I'm going to take a quick look here at the data using a subscription I have for myself. As you see, there was a couple other subscriptions out there that is managed for me. I don't have to worry about that. That isn't something that the consumer has to worry about. That's managed for you by the brokers and the cluster. So you don't have to worry if you're going to lose data. If you're not sure where you are, it knows where you are. So that's a nice feature. Namespaces are how we break things down. And I can have all the topics under a certain namespace. I can have different tenants here and, what clusters they have access to, what namespaces they have underneath them, and go from there. Makes it pretty easy to keep those isolated. But this guy crashed. Okay, so this is how hard it is to push data into Pulsar. It's literally, I have the broker and I have the name and my login, and then it just pushes the data where it needs to go. And if the cluster is hosted, I could just validate that it's doing by peeking in. Now, what's nice here is when I'm peeking through the UI, this is not changing what my current read position is. So if I'm a consumer, I could just have my own subscription here, and it's not going to affect other people. It's not going to mess up the ordering of the data or who is reading it or cause data to be lost. Not something you have to be concerned with in Pulsar. Let's see where this one. Yeah, to show you I am not a front end developer, as you can see by how ugly my web page is. This is a single page app. This is making a WebSocket call to Pulsar, and as new events arrive, it is just refreshing them. I could see if I have that running. Well, let's see where energy is. Yeah, as energy comes in, it'll get pulled into my web page through WebSockets. Pretty easy to do there. But just to give you an idea how those sort of things work. I was afraid my slides would crash there. Seems like we're getting hit here. Around lunchtime, everyone in the world is seems to be on Netflix, but what are you going to do? So this is one of the example apps. I like to call those couple of different open source frameworks out there, Flippin', Flink, Pulsar, maybe NiFi together, makes it very easy for you to grab data from somewhere, have it in a safe, durable storage, and send that somewhere else. I could start off with these edge devices. I could start off with a store, on-premise data center, or another part of the cloud. Wherever it is, doesn't really matter. For some of the use cases, I go directly into Pulsar. Sometimes I go through a gateway. Sometimes I use the native protocol. Sometimes it's MQTT. Sometimes it's WebSockets. Lots of different ways for me to get data into Pulsar. So I could do things like Pulsar SQL, Flink applications, or push it through a sync like a Kafka Connect, 2 different data stores, whether it's data lake storage, Postgres, Aerospike, Trinol, Influx, whatever your syncs are, wherever they happen to be running. There's a lot of them out there already. Some go through JDBC, some go through other mechanisms. Pretty easy to put whatever kind of security you may have there. Or again, I could have something like NiFi or Spark or something else, pull that data out, push it to a sync itself, or do additional processing. Pretty standard way to write these apps. Then, whether it's databases, apps, whether you're dropping into a data warehouse or a search index, same idea there. A common use case is nice here is if you're looking at some of the old style of doing this, things like ordering services, microservices, maybe dealing with JMS or ActiveMQ or some other messaging system, and then you've got to get it into something that Flink or Spark can work with. Having Pulsar is nice. This unifies all these application and data services use the same messaging cluster. So it doesn't matter if you're a mobile app, you're a backend service, you're a streaming application, all these can use the same system. You could use the same tiered storage, one place for all this data. So you could query it back and know, okay, this is the orders from 10 years ago. I still have a record of when they came in, what order they came in, and I could replay those if I need to. Let me get the line showing here. These lines drawing. This was one of the apps I was showing. Edge devices, get into NiFi, get into Pulsar, can do some deep learning there, get into Flink to do analytics, push it to a cloud store. Yeah, I guess I could have done that part later. Let me go here. See all these. We have a couple minutes left. If there's more questions, very eager to get them. If you're interested in Pulsar, I hope you are. We'll make sure you get these slides so you can contact us, whether through Slack, Twitter. We've got a monthly open source newsletter. I've got a lot of links and a lot of ways to contact me. All this information will be put on GitHub. So if you want to try out the apps, see how you build clusters, see how you build topics, see how you build different IoT apps, definitely contact me through there. There's also 2 free books on learning Pulsar, and we'll send out those links. One's on Manning, one's on O'Reilly, both of them really good. So hopefully, and there's a lot of conferences I'll be talking at, and those are all linked in there if you're interested. Do we have any more questions?
No, I think you explained too good, and then people, they don't have questions. Yeah, that was actually, I need to say, that was a subject I never kind of study at all, never done any kind of deep dive. That's actually, I've learned quite a lot today. That's
Very
really
cool.
Interesting.
And it's easy. If you've done SQL, if you sent data anywhere or read data from anywhere, you could use it, and all of a sudden now you're a streaming engineer. So that's nice. And it's really, you watch the data come in and out, and you're like, that's a nice way to be able to distribute the data. So instead of sending it one place and then other people have to figure out what to do with it, put it into a topic, can be shared among a lot of different apps. As new apps come in, you know, they get the contract there. They decide how they want to subscribe to it. They decide what they want to do. And they could decide if you wrote a new app next year, if you're using the tiered storage and, you know, you don't want your data to go away, someone could just say, give me the data from the beginning. And this app can act as if it's been sitting there for 2 years, get all the old data, process it, and be up to date as new events come. So it makes it a nice way to do those sort of things.
Yeah, I just got probably the last question. If you could share those slides.
Oh, yes. I'll put them. I'll make sure you have them so we can put them. I'll put them in the Slack.
Yeah.
I'll put them on
okay.
GitHub,
Yeah.
put them on SlideShare.
And then we can find the best way to share. Yeah, that's a good idea.
And I'll put them in PDF, but they'll be on my GitHub. I put all my talks in GitHub, make it easy. And I'll put in SlideShare. And if you look on Twitter, I tweet a lot. It'll be in there.
Okay.
You don't have to worry about that.
It's good to know. Yeah. Okay. I think that's pretty much it. And thanks so much, Tim, for spending this last hour here with us and everybody watching, let's say, live now, or we'll watch the recording later on. Yeah, that's really great. Let me just add my screen here again. And then, guys, before we go, one more time for us, as I said at the beginning, it's always nice and important to know how many people are connecting and following us. If you could just go to that link again, do a quick registration. And then for us, for Microsoft, is important. And then, as I said at the beginning, is a good way for you to get some additional information from Microsoft related to what just, Tim went through the last hour. I think that's pretty much it from me. Anything else, Tim, to add, or we are sorted, I would say?
No, I think we're in good shape. If you happen to be at KubeCon this week, come over to the booth. We got some giveaways, and I'll be on the virtual booth.
Okay.
If you have more questions, I'll be at KubeCon all week.
Okay. Thanks everybody for to joining the session, and I hope to see you next week again. Next week we have every Wednesday we are running session here in our community. Please make sure that you do the registration. Okay, everybody, thanks very much, and see you again. Thank you.